Welcome back, students. So we're in section 14.5 looking at numbers in standard form. So remember the phrase standard form in maths is used in every area. A quadratic in standard form looks like ax squared plus bx plus c. And so on. In any area we talk about standard form. Like if we were going to write simultaneous equations in standard form, we might see 3x plus 4y equals 8 and 2x minus 4y equals 11. That's standard form. And so you're about to realize an earth-shattering fact, and that is when we write down 365, it is not a number in standard form. Okay, it is a number in integer form. And if we wrote that in standard form, it would read 3.65 by 10 to the 2. Okay, let's deconstruct what I've just done there. I've taken the number 365 and I have taken a decimal place that lives here, and I've started moving it to the left, making the number smaller. And so if my number is getting smaller, I have to compensate for that by making my number bigger. Okay, so let's further talk about what is a standard notation number all about. So a standard notation number, such as the speed of light, let's look at the speed of light. So if we go to fundamental constants, so on page 46, and I just want to get you your bearings here, way back under contents, we say we have all the mathematics on the first page of contents, but this is the physics here, and it's very important when you think about it, because we're always looking to apply, where's my plus here, this one, and we're always looking to apply, you know, maths is the application of maths is really important, and there's lots of questions. We can get lots of interesting questions from up here for our junior cert and leaving cert courses. So we're going to jump up to page 46 like this. There's 47, here's 46. Okay, and we have lots of numbers here that are fundamental physical constants. So in physics we get very big numbers and very small numbers. Here's the speed of light in a vacuum, 2.997924. Well, we can call that 3 with 8 zeros on it. So will you write down 3 with 8 zeros into your copy? And we're going to write this in scientific notation. So if we're doing pen and paper maths, we can think of the fact, oh, you know what, I can make this bigger, I forgot. Yeah, let's make it, no, I think it'll limit me and I might end up shrinking again. Let's see. Yeah, that's as big as it'll go, but it's a heck of a lot better that way than it was. Okay, so we have the number 3000, and it would be, by the way, 3000 meters per second, but we can drop the units while we're working with it. So as I go this way, I'm getting smaller, and we literally just want to count 1, 2, 3, 4, 5, 6, 7, 8, and once we land here, we have created our coefficient, which is 3, and then you've got 10 to the 8, which is your multiplier. Okay, let's look at another number here. Let's look at how big is a proton compared to an electron. I mean, the mass of a proton divided by the mass of an electron. And let's just write that down here as 1836. Okay, so we have 1836. I want to write that in scientific mode. Will you have a go at that? Pause the video, have a go at that and see how you get on. Okay, welcome back. So you should have started with a decimal place here and gone 1.836 by 10 to the power of, you can literally count 1, 2, 3 by 10 to the power of 3. Okay, so now let's look at our calculator now, and me see where I could put that. Yeah, so okay, what I want to show you is how the calculator works. So I'm going to go bring you through the number formats. So if I clear that, I'm back to my, I have currently got number in scientific mode, but you can go enter setup, take option 3, which is a number format, and let's go to 3, 1. Okay, this says D for decimal. So that D there that my mouse is pointing at is the word decimal. Okay, so these are numbers in decimal format. Now whether there's a decimal place or not doesn't matter. Okay, that's a number in decimal format. And that's the standard, the sort of numbers you're used to. Let's take the number pi and do a shift equals to see it as an expanded decimal. Okay, now if I go back and say I want my calculator to be to 2 decimal places, let's write that down first. 3.141592654. Okay, now let's go into setup, into number, and let's into fixed decimal places, and let's go with 4 decimal places. Now as I press ST, it'll bring it out to 4 decimal places. It'll bring it back to the exact expression and over and back like that. Okay, now I think I pressed 4. I can't remember. I'm going to double check though. Or did I press 5? If it was 4, it's decimal places, and if it's 5, it's significant figures. Let's bring it to 3 decimal places. Shift, setup, number, fix. Sorry, fix. Oh, shift, set. Oh, shift, setup, number, fix. Oh, and I have to just select it, right? So if I press 3, that's fine. And now if I do ST, it's gone to 3 decimal places. Okay, well, we're not here to study just how you should limit the accuracy of your number. We're here to talk about scientific notation or numbers in standard form. So you then want to go back to Shift, Setup, 3 and go into scientific mode. And here again you're given the choice, well, what kind of accuracy do you want on your coefficient? So we'll pick 3 again. Okay, and let's go to the book and do some calculations. Write 0.037 in scientific notation. So I'll clear. Now I just don't want to neglect the fact that we can do pen and paper maths as well. So when we're given 0.037, the decimal place now is too far to the left, not to the right. So he's actually going to move that way. And if he's moving that way, your power figure is moving this way. And just before I go on, I just want to mention something about the domain of different numbers. So for example, when we say a times 10 to the n, a is a real number. Okay, it's a member of the set of real numbers, whereas n is an integer. Okay, so n is an integer. It can be a positive or negative or 0. And a is a real number, and we can just choose to decide the level of precision we want. So you're going to hear that. That's a lovely thing from functions where we talk about the domain of different numbers. Okay, great. We're doing great here, lads. So now we go back to our 0.00. Well, it wasn't 0.0037. It doesn't matter. Let's do 0.0045. So if I'm going, so I have a little trick for you here. We could say that this is by 10 to the 0. Now as I go this way 3 places, my power drops by 3 places. So that will give you 4.5 by 10 to the negative 3. Okay, but how about the calculator? Well, we're in scientific mode. Now the other thing is about the scientific mode, I'm just thinking Shift menu, 3, and because these questions, I can't trust them to know how many decimal places they need. When they start asking us for a lot, I will say to you, do we really want to be filling them all in? But right now I'm going to go with 2, and we'll just go with the 9 option. Okay, so now we're at as precise a calculator as we can have. Okay, so clear the decks, 0.0045 equals. Yes, first it gives it to me as a fraction, but I have an ST choice now, 4.5. There's all your precision. But I also have the shift equals option, which we're going to look at as we move forward. Okay, so let's talk about this problem here. First, I want to do it on paper. So we have 8.7 by 10 to the 3. It's a big number, and we have 1.84 by 10 to the 2, which is a smaller number. So we should try to move everything up to the bigger multiplier, because it's going to dominate the calculation. Okay, so we leave that like this, and we want to convert the other one up to a 10 to the 3. So I want you to think about, I'll just move this here. So I've written this, and I've written this 10 times too big. So if I've written this 10 times too big, this one has to be written 10 times too small, which is 0.184. Okay, now we're adding them together, so we're going to get 8.884 by 10 to the 3. And we can check that that's going to happen on our calculator. Now this is very important. I'm about to show you how to fill in a number in standard form. It's 1.84. You have to use this button. Don't think I can use multiply 10 to the power of x. It's completely different. And the reason is that the 1.84 by 10 to the 2 that I've just filled in is a single number, not a numerical expression in this calculator. I think we will go, as we go along, we'll see what it's like in the new calculator. There might be an issue and we might end up using brackets. So just keep that in mind if you have the newer calculator. I'm not saying anything for sure yet until we test it. 3 goes here, and I can do equals, and if it doesn't like, and then ST, it won't go anywhere. So 8.884. And of course, if I want so many places, I could have set that earlier, or we can just do our usual rounding anyway. Okay, so multiplying and dividing numbers in this mode is no different than anything else. I'll do some pen and paper exercises here real quick. So when you're going 3.6 by 10 to the 2, what do I have to do? Oh, they want me to turn this into a 10. If I turn this into a 10 to the 0, I have made this number smaller. I have on my number line, I've gone from 2 to 0. So that's getting smaller, so this has to get bigger. 360. So you're counting your movement of your decimal place. I'm going to do another one now, and I'm going to show you a trick. If you have to do pen and paper, if you're being forced to do pen and paper and not to use the calculator, you'll go like this. 14.3. By the way, this is called engineering notation, where this number can actually float around a little bit. Okay, so this is called engineering notation. Okay, and you've got your 14.3 by 10 to the 4. Okay, but now the way I want to look at this is 14.3 space 10 to the 4. And of course that is dropping because we're getting rid of it down to 0. And if that is dropping, this number is getting smaller, so this number has to get bigger. So basically the power dropping is the same as the decimal place moving to the right. Okay, so basically this means if you're trying to do this sum, I'm trying to move the decimal place to the right 4 places. So we can count that out. 1, and instead of just doing a loop, I can make a note. 1, 2, 3, 4. Okay, and we have 143000. Okay, but the other way would be to turn your calculator, shift setup. Oh, come on, shift setup number and go back to normal mode 3, 1. Okay, and clear the decks and just fill in what they're showing you here. 14.3 by 10 to the power of 4, and just hit equals and it's done as well. Okay, so I'll just also do, I mean most of these are pretty trivial, but we'll also just do, so I'm not going to go with the book guys because it's too frustrating that I'm trying to teach you everything I could teach you and the book is very much not. So basically I just want a very small number now. Okay, so let's go with any particular small number. Let's go with 0.00035. Okay, and I want to convert that. No, it's the other way around, sorry. Well, if I want to convert, no, I want a small number written like this. 3.7 by 10 to the minus 4. Now if we start thinking about this in pen and paper, you say I want that power to go all the way up to 0. Okay, so it's going to go up 4 places, and if I'm going up 4 places my decimal place is going that way. Okay, so I'm going to start with my decimal place here. So we're going to have leading, no I'm not, that's getting bigger, this is getting smaller. Oh yeah, so that's getting bigger and it's getting smaller. So we're going to have leading zeros. So we can count 4. So negative 4 means move the decimal place to the left. Positive 4 means move the decimal place to the right. 1, 2, 3, 4. 0.00037. Okay. So we'll go down now and do these. But you don't want to be doing them with pen and paper, guys, just to show you how quick it is to fill them in. Straight along 3.8, and I'll just say to the 2, well I want to be, it isn't 3.8 to the power 2, I'd say scaled to the 2. Okay, 3.8 scaled to the 2 plus 1.7 scaled to the 3. Maths is a very creative field, and you know, different people will have, it isn't all about just finding out what's the official way of saying things, and there may not even be one. So that's why I'm saying we have to come up with our own language while we're having a conversation. So let's call it scale to them. We hit that and we get 2080. Okay, and we'll see what the SD does, but it won't do anything unless I'm in scientific mode, so we'll leave that at that. Of course we could convert it, and there's no challenge with any of these minuses or pluses. So I'm going to get on to some of the more difficult questions. Or at least maybe we'll fill in question 11 there, say, which looks a little bit contrite, or kind of, I can't think of the word, but complicated is slightly, but it's not very complicated. So I'm doing question 11 here. So I just want to see too, do you want me to display anything to the side here? Window, pop-up display. It might be nice to have it. Just clear the decks there and have my pop-up display. Would it feel a bit confusing if I went way over here to the left? Let's take our book to the right. Make our screen, I'm getting confused now. Let's take our calculator. Let's post in case I make a mess of this any further. I hope the audio is good. I'll see you in the next one.